Welcome back to the channel. In this video, we're excited to introduce LLAMA 3.2, a groundbreaking model that's pushing the boundaries of edge AI and vision capabilities. We'll be testing this state-of-the-art model across multiple areas, including image understanding, visual representation analysis, and even X-ray image interpretation for medical application. We'll also explore its potential in practical tasks like extracting data from documents, counting, and even recognizing car damage and identifying vehicle type. Stick around to see how LLAMA 3.2 can revolutionize these use cases and more. Now, let's begin with our first test, starting with this image, which is a visual representation of the LLAMA 3.1 GPU requirements for the 70 billion parameter model. We'll drop the image in and ask it to explain. As you can see, it has provided accurate information. It correctly displays the data for all the different quantization levels and has understood exactly what the image is about, along with the details it contains. Moving on to the next image, we'll drop in a visual representation of primary flight commands for a plane. As you can see, the model has once again understood the image perfectly, providing a clear description. It identifies the image, including the numbers on the plane and the blue stripes. The description it provides is spot on. Next, we'll test it with a receipt from Staples. In this case, we have two items, Kleenex Ultra, purchased twice, here and here. We'll ask the model to extract data points, including the items' names, prices, and the total amount. As you can see, it has correctly identified and extracted all the information. This is really impressive. The model is performing incredibly well. Now, moving on to our next test, we'll input a photo of the weekend to see if it can recognize him. Interestingly, the model declines to provide a name or any specific information about the person, stating that it cannot assist with that. Let's try with an image of the Mona Lisa instead. The same issue occurs again. It doesn't seem to recognize the image. I'm not sure if the model is genuinely unable to recognize the picture, or if it's using safeguards to avoid identifying people. So let's try telling it that it's a painting instead of a person. So after specifying that it's a painting, the model responds correctly, identifying the image as the Mona Lisa by Leonardo da Vinci. This shows that the model can indeed recognize people and images, but has safeguards in place that prevent it from naming individuals directly. However, when we clarified that the image was of a painting, it correctly identified the artwork and provided the relevant details. Moving on, we'll now test it with an image from the release of Grok by xAI to see if it understands the context. As you can see, the model has hallucinated. It's telling us that Grok is a cryptocurrency, which is incorrect. This might be due to the release of Grok happening after the knowledge cutoff date of the model we're using. However, what's interesting is without us specifically asking, the model correctly identified Elon Musk and recognized that the company is xAI, which is accurate. Next, we'll provide the model with a thumbnail from one of my videos to see if it can understand what the video is about, just based on the thumbnail. Interestingly, the model did understand the content of the video accurately, based solely on the image, which is impressive. Moving forward, we'll conduct an X-ray image test. In this X-ray, there's a foreign object in the chest. Let's see how well it can recognize the details. As you can see, the model correctly identified the foreign object and provided accurate and detailed information. In the following X-ray, we have someone with a broken wrist who also has metal pins and a cast installed. Let's check if the model can pick up on these details. Once again, it provided highly accurate and detailed information. I'm genuinely impressed by how well this model is performing. Its capabilities are incredible. And given that this is just the 11 billion parameter version, I can only imagine how good the 90 billion parameter version must be. Now let's test the model with an image of LinkedIn's logo to see if it recognizes it. And as you can see, it did recognize LinkedIn correctly. Next up is a test to see if it can count people in images. We'll give it a picture that has 6 people in it and ask it to count how many males and females are present. While it got the number of girls right, it miscounted the number of guys. There are only 6 people, 3 guys and 3 girls, but the model said there were 4 guys and 3 girls, which is incorrect. Let's continue with the next test. We'll give the model an image of ducks. There are 3 ducks in the image, and let's see if it can count them accurately. As you can see, it did count them correctly, confirming there are indeed 3 ducks. Now moving on to the next test, we'll give it an image of cars in a parking lot. There are 7 cars in total, and let's check if the model can count them correctly. Interestingly, the model miscounted, stating there are only 6 cars, when in fact there are 7. Next, we'll test the model on an image of a car that has been involved in an accident. First, let's ask it to identify the make and model of the car. It correctly identified that it's a Honda. Now let's ask it to describe the damage. Once again, it provided accurate information, detailing the visible damage to the car. For a more complex test, let's ask it to estimate the cost of fully repairing the damage. The model did provide an estimate, although I'm unsure how accurate the numbers are. Nevertheless, it gave us a fairly reasonable repair estimate based on the damage it identified. Overall, I think this model is incredibly promising. It performed exceptionally well in most of the areas we tested. And keep in mind, this is only the 11 billion parameter version, not even the 90 billion parameter one. So this level of accuracy and performance is truly impressive. Thanks for tuning in, and I'll see you in the next video.